Welcome everybody to another video at the Ben Impact. Today we're going to discuss something different. We're going to talk about alcohol, the history of alcohol, the way it affects our body, the way our body metabolizes alcohol, and a whole range of things. Before we jump in, as always, if you find any value in this content, please subscribe, share, comment below, and let's get started. The history of alcoholic beverages is shrouded in mystery and dates far back to ancient times. Alcohol is one of the oldest and most widely used drugs. Wines and beers have been made in several hundred societies, ancient societies, playing a different role and significant role in personal and social ceremonies, especially rites of passage and activities like births, initiations, marriages, and funerals. Alcohol production likely began with early farmers observing fermentation in fallen fruit, leading to the development of alcoholic drinks through trial and error. Around 10,000 years ago, organized alcohol production started using honey and wild yeast. By 6000 BC, grapes were cultivated for winemaking in the Black and Caspian Seas region. Over the millennia, civilizations in Mesopotamia, the Hebrews, the Egyptians, the Greeks, the Romans, the Chinese, and the Indians became proficient in creating alcoholic beverages such as wine and beer. These drinks found their place in various aspects of life. Alcohol is a powerful drug, capable of giving profound effects on the body. If you ever had a chance to observe someone under heavy influence, you probably witnessed its mind-altering effects and their behavior. From a chemical perspective, alcohol is a simple molecule. The term alcohol is a blanket descriptor of a class of organic compounds that share common properties. Within this category, various types of alcohol exist, most of which are unsafe for human consumption. Consider, for example, methanol. It is used to make antifreeze and can be lethal if ingested by humans. The form of alcohol that is found in alcoholic beverages today is called ethanol. How does fermentation work? Fermentation occurs when sugar-containing foods like grapes, grains, berries, or honey are exposed to warm air. Yeast from the air turn to sugar into alcohol and carbon dioxide. This process primarily revolves around the metabolic pathway known as glycolysis, where glucose undergoes a series of transformations into simpler molecules. When yeast ferments sugar under anaerobic conditions, in the absence of oxygen, glucose is converted into a pivotal intermediary compound called pyruvate, essential in cellular metabolism. The next step involves the conversion of pyruvate into ethanol. During this conversion, carbon dioxide is liberated, contributing to the distinctive effervescence found in alcoholic beverages. Fermentation typically continues until the alcohol content reaches a certain level, usually around 11 to 14%. At this point, the high alcohol concentration can inhibit yeast activity and fermentation stops naturally. The process of distillation instead is a method that elevates the alcoholic content of certain beverages. In this process, fermented alcohol is heated, causing it to evaporate. The resulting vapor is collected and condensed back into liquid form. These distilled products, commonly known as hard liquors, are quantified by their proof to determine the alcohol content. Examples of such hard liquors include whiskey, vodka, rum, and gin. The proof of a beverage is exactly twice its alcohol content. For instance, a distilled product labeled as 80 proof contains 40% of alcohol by volume. When we consume alcohol, it is quickly absorbed into our bloodstream without much digestion. While a small amount may be absorbed in the stomach, the majority, around 80%, is absorbed in the small intestine through simple diffusion. The rate at which alcohol is absorbed is influenced by various factors such as drinking on an empty stomach, which leads to quicker adoption. On the other hand, Having food in the stomach slows down alcohol absorption, but delaying gastric emptying. The type of food consumed does not affect absorption. However, the alcohol concentration in the beverages consumed generally increases the rate of absorption. Once absorbed, alcohol enters the bloodstream and circulates throughout the body. You may have heard of the term blood alcohol concentration. That is the amount of alcohol in a person's blood. A BAC, or blood alcohol concentration, of 0.10 indicates 1/10 of a gram of alcohol per deciliter of blood. Shortly after consuming a standard drink, like 12 ounces of beer or 1.5 ounces of 80 proof distilled liquor, BAC starts to rise, typically peaking within 30 to 45 minutes. As more alcohol is consumed, it accumulates in the blood because the rate of alcohol metabolism is lower than the rate of absorption. The legal limit for driving is a blood alcohol concentration of 0.08 grams per deciliter, although this limit may vary depending on factors like an individual's weight and gender. The alcohol impact on blood alcohol concentration is influenced by the body water content and tissue composition. Alcohol dissolves very well in water, both inside and outside cells. However, different body tissues have varying water content, affecting how quickly the body absorbs the alcohol. Muscle tissue, rich in water, absorbs the alcohol rapidly, while adipose tissue, with lower water content, absorbs it more slowly. As a result, an individual's BAC can be influenced by their body composition. So two people with similar body weight but different body compositions may have different BAC levels. This happens because alcohol moves from the blood into lean tissue until a balance is reached, while adipose tissue retains little alcohol, keeping more in the bloodstream. Additionally, physical size matters. Larger individuals have more blood and body fluids than a smaller one, leading to lower alcohol concentration in larger individuals who consume the same amount of alcohol as smaller individuals. Alcohol acts as a central nervous system depressant, slowing down brain activity. Even a small amount of alcohol can induce euphoria, and it selectively targets specific brain regions governing our senses, thoughts, and behaviors. This effect is known as disinhibition, which promotes feelings of relaxation of sociability. However, as blood alcohol concentration rises, disinhibition can impair judgment and reasoning. Brain regions controlling speech, vision, and involuntary muscle movements can become affected. Continued drinking may lead to unconsciousness. In extreme cases, the alcohol concentration in the bloodstream can reach lethal levels, leading to intoxication. According to 2018 data from the WHO, alcohol consumption carries a significant global health burden, causing roughly 3 million deaths annually, which constitutes nearly 14% of total mortality among individuals aged 20 to 40 years old. Habitual alcohol use is associated with over 200 diseases affecting various organs, including the brain, heart, gastrointestinal tract, and liver. When a person drinks alcohol, their body must break it down into safe components for elimination. Contrary to popular belief, consuming certain foods or drinks does not speed up this process. While small amounts of alcohol can be removed through breath, sweat, or urine, the liver is the organ responsible for its metabolism. However, the liver possesses limited processing capacity. An average person can metabolize only 0.5 ounces of pure alcohol per hour. The liver is highly sensitive to alcohol intake, as it is the primary organ that is responsible for metabolizing alcohol. Extended heavy alcohol consumption can lead to liver damage, disrupting its normal functions. This harm occurs due to buildup in toxic ethanol byproducts, some of which may even possess carcinogenic properties. Various mechanisms lead to alcoholic liver disease, with impaired lipid metabolism, intensifying inflammatory reactions, and inducing fibrosis. This can result in unhealthy conditions including alcoholic fatty liver, hepatitis, cirrhosis, and liver cancer. Other consequences of heavy drinking affect the vitamin A metabolism in the liver. Vitamin A plays an essential role in vision, leading to potential vision problems, especially at night. Excessive alcohol consumption can have a negative impact on the cardiovascular system, leading to alcoholic cardiomyopathy, damaging heart muscles cells and heart muscle cells over time. Regular exposure to high level of alcohol can weaken the heart muscles, making it less efficient at pumping blood to other organs like the lungs, the liver, kidneys, and brain. Additionally, alcohol abuse is a contributing factor for both acute and chronic pancreatitis. Pancreatitis is a very difficult word to pronounce. A long-term inflammation of the pancreas. I was curious to investigate the potential correlation between aging and alcohol consumption. I found that certain lifestyle habits have been linked to accelerated atrophy in certain brain regions. Two of the most extensively studied adverse factors in this regard are heavy smoking and heavy drinking. Individuals diagnosed with alcohol use disorder often experience a significant reduction in regional gray and white matter volumes, notably in the medial prefrontal and orbitofrontal cortices. The decline in brain matter tends to accelerate as individuals age, particularly among those who have been chronic alcohol drinkers. In essence, heavy alcohol consumption has a detrimental effect on the brain. While these observations highlight the adverse effects of alcohol on brain health, we must consider the interplay of genetic factors, individual differences, and environmental influences, all of which contribute to the complex process of brain aging. In other observational analysis, a significant correlation was identified between high alcohol intake and shorter telomere length. Now, telomeres are like protective caps of the ends of our chromosomes, and they're made up of repetitive DNA sequences. They serve to shield our chromosomes from damage. As our cells replicate, they lose a bit of these telomeres, about 50 to 100 DNA bases each time. When telomeres become too short, cells can keep dividing, and they may even die. Shorter telomeres have been linked to various age-related diseases, such as Alzheimer's disease, cancer, and coronary artery disease. So measuring telomere length can provide insights into the biological aging process and the risk of developing these health conditions. To provide some context, compared to individuals who consumed less than 6 units of alcohol per week, that are equivalent to about 2 large 250 milliliters of glasses of wine, those who consumed more than 29 units weekly, approximately equal to 10 250 milliliter glasses, or 14% of alcohol by volume of wine, experience between 1 to 2 years of age-related change in their telomere length. People who were diagnosed with an alcohol use disorder had much shorter telomeres compared to those without the disorder. In fact, this difference was equivalent to experiencing 3 to 6 years of age-related change. This suggests that excessive alcohol consumption, especially at high levels, can directly affect telomere length. The way alcohol might impact telomere length is through a combination of factors like oxidative stress and inflammation. Oxidative stress has been shown to affect telomere length both in laboratory settings and in living organisms. When the body metabolizes ethanol, it can generate reactive oxygen species and reactive nitrogen species, which are harmful molecules that contribute to oxidative stress. Additionally, ethanol can reduce the levels of important cellular antioxidants like glutathione, which worsens oxidative stress. Over the past decade, alcohol consumption guidelines have evolved with new research and emerging studies, reflecting a growing understanding of the complex relationship between alcohol and health. In 2015, the dietary guidelines for Americans recommended moderate alcohol consumption, allowing for 1 drink per day for women and up to 2 drinks per day per man. This stance was based on various studies suggesting that moderate drinking could potentially contribute to longevity and decrease the risk of certain health conditions, including cardiovascular disease, strokes, gallstones, age-related memory loss, and type 2 diabetes. However, it's important to note that these studies had limitations. Nonetheless, they still found strong evidence supporting the benefits of moderate drinking. In January 2023, the WHO released a statement asserting that no level of alcohol consumption is safe for human health, citing a 2021 studies estimating that light to moderate drinking, 1 to 2 drinks per day, was responsible for 23,300 new cases of cancer in the EU in 2017. While the potential benefits of light to moderate alcohol consumption are acknowledged, experts caution against excessive drinking due to the well-documented risks and harms associated with alcohol, especially heavy or binge drinking. Consuming more than 10 grams of ethanol per day increases the risk of premature mortality and can raise blood pressure, leading to hypertension. Furthermore, the protective effects of moderate alcohol consumption seem to diminish with heavy episodic drinking, increasing the risk of cardiovascular diseases. To establish a safe level of alcohol consumption, scientific evidence is needed to demonstrate that it does not increase the risk of illness or injury. Some studies suggest that light alcohol consumption may offer modest protective effects against diseases such as cardiovascular diseases or type 2 diabetes. Some studies suggest potential health benefits associated with lower alcohol intake, including reduced risk of cardiovascular disease, diabetes, and mortality. Red wine with its polyphenols provides antioxidants and anti-inflammatory effects. At low doses, ethanol plays a key role in these potential health benefits by boosting HDL cholesterol, thinning plasma, lowering fibrinogen, promoting fibrinolysis, reducing platelet clumping, and improving blood vessel lining function. Light to moderate alcohol consumption has also been associated with reduced risk among patients with rheumatoid arthritis. A meta-analysis of studies found a reduced risk of developing rheumatoid arthritis among those who consumed alcohol up to 12 grams per day. There are approximately 8 drinks per week compared to non-drinkers. After presenting this research, it's important to recognize that epidemiological studies on alcohol consumption face methodological challenges. These challenges include confounding factors, defining light to moderate alcohol consumption, competing risk factors for disease, choice of comparison groups, and limitations in self-reported alcohol intake. These complexities can make it difficult to precisely determine the relationship between alcohol use and overall mortality risk. If you choose to consume alcohol, do so responsibly and in moderation. Binge drinking is harmful, and be aware of your own tolerance and how alcohol affects your personality. Establish your own personal limits for alcohol consumption based on your health, lifestyle, and goals. If you're going to drink, plan ahead for a safe way to get home. Arrange for a designated driver or use a ride-sharing service. Don't drink and drive. After I provided with all this evidence, there are studies that say that alcohol is good or no amount of alcohol is safe. However, as we saw in this research, epidemiological studies are not an easy thing because it's difficult to study habits of human nature because we have so many variables in play. And honestly, we still do not know if alcohol is beneficial for some and detrimental for others. The choice is ultimately yours, so be responsible and drink responsibly. This concludes our first part of this video, and subscribe, share, comment, and I will see you next time.